little bit. The meeting is getting recorded. Yeah. Over to you, Sheetal. Please go ahead.
Thanks, Ganguly. So very good evening and a warm welcome to all the business leaders, professionals, our esteemed faculty, and everyone here this evening to our Power Packed workshop on Gen AI for Business Leaders, which is happening today, that is 16th of March, and tomorrow, 17th of March, from 6:30 to 9:30. From insightful presentations and interactive discussions, we encourage each of you to actively engage and share your perspectives throughout the workshop. This would enrich our collective learning journey. Coming to who we are. Now, KPI Ladder, formerly KPI Consulting, started in the year 2013. And we are one of the market-centric providers on next-gen technologies with a decade-plus years of experience in expert-led consulting and training across India, Middle East, and Africa. Just to name a few of our clients, we worked with Sapient, Mindtree, eClerx, ExxonMobil, Sony, Sonata, Qatar Petroleum, and many more. So to just give you a brief introduction about our faculty and chief mentor, Mr. Prashant. Hello, good evening, Mr. Prashant. Hello. Hello.
Yeah, very good evening, Sheetal.
Yeah, hi, Mr. Prashant. So I would just like to introduce our faculty, Mr. Prashant. So having 18 plus years of experience in data science and multiple certifications such as computational data science from IISc Bangalore, he is actively engaged as a trainer with MIT MicroMasters, IIT Guwahati, and industry leaders such as BMW, Bosch, Microsoft, Oman LNG, Tata Power, and many more. He has trained 5,000 plus participants from the corporate and the academic background and has also published over 25 papers in the top-notch journals like Elsevier and Scopus and IEEE. So before we proceed for the session, I would like to ask the participants to have a quick 30-second introduction of each of you. So may I request you to also switch on your camera while you introduce yourselves. Could we just have the participants to share a brief 30-second introduction?
Sure. Hello, everyone. I will go first. This is Himanshu.
Would request you to please switch on the camera while you introduce yourself.
Yeah, there is some issue, I guess. So
no, okay, no problem, no worries.
No problem.
But yeah, if it works, then maybe later I will switch on.
And also one more thing. So I have given the host to Prashant sir. So if you can keep adding the host, I think few are there in the waiting in the queue. Let's join. I think Shraddha have joined. Yeah, Shraddha, you're there, right? Okay, I think few would be are joining. Shraddha, can you hear us? Okay.
Yes, I can hear you now.
Okay, wonderful. Okay, so over to you, Himanshu. Please go ahead. You are introducing yourself, right? Maybe a quick 30 minutes, 30 seconds should be that will be great. Okay.
Thanks everyone. Thanks a lot. This is Himanshu Vaidya from Pune. I am having 20 years of overall experience in the field of IT and also working in data science and data engineering space from past 10 to 12 years. Keen to attend the session and gain insights from the same. Thank you.
Thank you, Himanshu. Who'd go next?
Can I go ahead? This is Asim Thalia.
Yes, please, Asim sir, go ahead.
All right. I'm sorry, I won't be able to switch on my video. Reason being is that I'm about to go to a taxi now, and I'm dialing from mobile. All right, I do have 20 plus years of experience in IT industry and worked with various companies, Microsoft, RBS, UHG, Exchanging, DHS Group, now working as an associate director with Divine Solutions, and not specifically worked in data sciences, but primarily investment bank, retail bank, and e-commerce, insurance, healthcare, mortgage. And yeah, that's my overall 20 plus years of journey with that industry.
Should I go next?
Please go ahead, Payal.
Hi, good evening, everyone. My name is Payal Chopra, and I've got 20 plus years of work experience in marketing. I'm a marketing professional, and I just completed a 1 year senior management program from IIM Calcutta. We just completed it on 1st March. And I really look forward to this because I think everything is moving into this space now. There's a lot of talk on AI, and I think it's going to be really useful for business leaders of tomorrow and even today. So I really look forward to this, and thank you.
Absolutely, Payal. Thank you. Who would go next?
Hi everyone. Myself Bhaskar Pupala. I'm based out of Hyderabad, and I have around 16 years of experience into cybersecurity and practices. Currently, I'm working for a company called Unisys at a senior security managerial position. Previous to that, I worked for MyGlam as a head of information security, and I am also coming from a pure tech background. And recently, I've done my business management along with Payal, who is in our group, and we both are from IIM alumnus background. And yesterday I just started my new career as a professor at the Oxford University. From this course, I'm expecting to learn how to use AI in a regular day-to-day basis so that it could ease in some of the regular manual tasks. So that's my expectation from the program. Thank you.
And just to add, thank you, Bhaskar, for introducing me to this group. He made me join this. Thank you.
Thank you, guys.
Thank you, Bhaskar. Thank you for your introduction. Next, who will be next? Yeah, Shraddha, you want to introduce? Or I see that Arif sir had. Okay, Tanya, go ahead, please.
Hi everyone, Tanya Das here. So I'm having 9+ years of experience in IT, and I'm a founder and CEO of IT company. And recently we are working on the AI project. So I would like to explore the things so I can implement those Gen AI in my project. Thank you so much.
Okay, thank you, Tanya. Shraddha, no, we cannot able to hear you. So you can just check with the mic. And meanwhile, if someone who want to introduce.
Is it okay?
Yes, please, Arif sir, please go ahead.
Yeah. Hi everyone, my name is Arif Ahmad and I work in Oman as an IT professional. I have got almost 20 years of experience in IT training and education services. I'm a Microsoft certified trainer and focusing mostly on the database and IT infrastructure technologies. Thank you so much.
Thank you, Arif sir. Thank you so much for introducing. Who is next?
Telugu, sir.
Yes, Ramesh sir, I can hear you. Please go ahead.
Great, thank you. So I have 20 years experience in banking and risk management side. So I have done some courses on generative AI with respect to how can we leverage Gen AI in product management, program management. So I also conducted some trainings internally also to make my team aware of this kind of technologies. I would like to explore more about different use cases and how can we use Gen AI and make and leverage it for the best benefit of the deliveries.
Thank you, Ramesh sir. Thank you. Who on the left? Ganesh sir, you want to go ahead?
Okay, I will just take 2 minutes. My name is Ganesh Jagnade. I am working in Fujitsu India Private Limited as a project manager, bilingual project manager. And it was just coincidence that I am working in our delivery side and I got a AI project where the client is asking about the research. So I thought like this is a good opportunity to understand further more. So I'm here. Thank you. Thank you very much.
Thank you. Shraddha,
Hey, hi. Am I audible?
Yes, you are now.
Okay, I joined from phone. I don't know what's the issue.
Okay.
Anyway, hi everyone. I'm Shraddha Silarka. I carry close to 20 years of experience, basically in technology and fintech organizations. I currently work with Northern Trust and head the one of the products from APAC. So, looking forward to this session. Thank you so much.
Thank you, Shudha. Anyone left apart from Mr. Vijay? You'd like to go ahead? Mr. Satish, is it possible? I think you have dropped a message that you're driving, so just take, if possible, 2 minutes, 30 seconds introduction. Right, so if not, then over to you, Prashant San. So please go ahead and start our much awaited discussion or workshop.
Good evening, everyone, and a very warm welcome to this webinar on generative AI for business leaders. My name is Prashant Kanarudi.
Prashant sir, one request. If I think a few are there in the waiting list, if you can add them, it will be really, or they're waiting.
Yeah, definitely. Sure.
Mahesh, Mahesh is there.
Yes. Sorry, I was not able to see the participant list. That's why I'm missing. I have turned on the participant list now, so I should be able to see if someone joins.
Okay. Is it possible? Mahesh, are you there? Can you able to hear us? Is it?
Yeah, I can hear you.
Okay. So we have just finished our introduction. If you can quickly give your introduction, 30 seconds should be really great. And then Prashant sir would be taking forward for this workshop.
Hey, no problem. Hey, hi everyone. This is Mahesh. I have more than 2 decades of experience in software. Currently, I'm working as a director of engineering at WorkFusion, and we are focusing on the integration of the LLM in our workflows. So, just for the learning purpose, I have joined this course.
Thank you, Mahesh. Thank you. Over to you, Prashant sir. Please go ahead and start.
Sure. Thank you. My name is Prashant Kanarudi, and I have spent past 2 decades diving deep into the world of artificial intelligence, machine learning, data science, deep learning, generative AI, and so on. Let's dive deeper into the generative AI. As you can see on the slide, AI has taken a significant step forward. We are no longer limited to the machine mimicking human intelligence. Generative AI allows us to unlock a whole new world of creativity. Imagine an AI that can generate entirely new content of data and even creative text formats. This is the power of a generative AI, and it's actually fueled by a vast amount of data set that's available in the world. Across the industries, generative AI is revolutionizing, and Gen AI is basically it's revolutionizing, and we can see that how the businesses operate and innovate. So let's start with a quick definition of artificial intelligence, or AI in short. AI refers to the intelligence demonstrated by the machines in contrast to the natural intelligence displayed by the humans. It's not about replicating human thought exactly, but we know that It's all about enabling the machines to learn, reason, solve the problems, and also basically make decisions. Just to illustrate this, simply think about how a recommendation systems work on streaming platforms such as Netflix. When you watch a particular movie, it suggests very similar shows which you might enjoy. That's the AI in action. This is also just because you might have already given some of the feedbacks about the past movies or the shows which you have watched so far, saying that I like this movie, I don't like this movie, it's not for me, like that. So there are several options. Whether you really like it, you just like this, or you hate it, you really don't like it, something like that. You have different categories in which you normally provide the feedback. More you provide feedback, machine learns more about your interests, and the recommendation system basically analyzes your viewing history, the preferences, along with the data from millions of other users who are very similar to you. This is just because the model which runs on the background tries to identify the patterns and suggest the relevant content. This is just one example of how the AI is already impacting our everyday life. So in general, there are three types of artificial intelligence. So the first one, as we can see, it's called as narrow intelligence, very specific. It's called also called as a type 1. It's a goal-oriented intelligence. There is a very specific goal, and the AI model tries to achieve that. The second case is it's a general intelligence. It tries to replicate the human being as. And the third one is artificial super intelligence. In short, it's type 3 or ASI. It's beyond human intelligence. You can try to have a fully automated cars or humanoid robots, etc. are the examples. Though we have not achieved complete or the perfectness in this particular aspects of the super intelligence, but definitely in soon future, we will be seeing the products coming out for this as well. Now, let's delve deeper into the specific area of AI called Gen AI. This is this is very exciting, I would say, subfield that focuses on empowering the machines to create entirely new data and even very creative text formats. So we know that we are using many tools these days. We have ChatGPT, we have the Ping AI, we have Google's Gemini, right? Those are some of the tools which are available for us to use and test it for free, definitely. But yes, there are paid versions of those tools are available, which will definitely help us using the full power of those trained models. We'll come to that in a while. So this Gen AI works by utilizing the machine learning models trained on massive amounts of data sets. These models can basically learn the underlying patterns and also the relationships among the data sets. This allows them to generate realistic as well as the original outputs. For example, the text generated by any of these models, such as, let's take an example of ChatGPT. So if the ChatGPT generated a text, if you try to check for its originality, what happens? You will find that this is the original text because it's a natural language, right? It's not copying the contents from anywhere else. That's why you can say that, yes, this is original data. So natural language. Okay, so let's take up an example. Consider online furniture store. AI can analyze the data on existing products, customer reviews, and even the current market trends. Using this particular information, it can automatically generate very unique and informative product descriptions for each of the items. This not only saves the business time and the resource, but also ensures consistent, high-quality product information for the customers. Now, we basically explored what is AI and what is Gen AI. And let's dive into the exciting ways it can supercharge our businesses. So Gen AI basically offers a wide range of benefits across various departments. Here is just few key areas where it can make a real impact. Say, personalized customer experiences. Imagine that crafting a highly personalized product recommendation, marketing campaign, or maybe the content tailored to each of the customer's unique preferences. This Gen AI can analyze vast amounts of customer data and make this a reality, leading to increased satisfaction and the sales. Let's look at the content marketing automation part. Normally, we struggle to keep up the content creation. Gen AI can help us. Anyway, at the later stage, we will be looking into the examples in terms of hands-on. This is just to give an introduction what this Gen AI can. So we were looking at the content marketing part. The Gen AI can generate compelling marketing materials like social media posts, the blog articles, and video scripts. So this allows you to focus on the strategy while Gen AI takes care of the content creation, saving you valuable time as well as the resources. Then product development and innovation. So considering this, accelerate the product design and development process with the Gen AI. So this is how we can generate new product ideas, simulate the different prototypes, and even identify the potential flaws. This basically opens the doors for faster innovation, bringing cutting edge products into the markets very quickly. All right. So then
Prashant, sir, one more thing. I think the audio is coming a little late. I hope anybody's facing this kind of issue, or it's only with my system.
For me as well, the same thing.
Same.
Okay. I think we can probably switch off the video from your end, Prashant.
Yeah. Just give me a second. I'll do that.
Okay.
Just give me a second. Is it fine now? I hope you can see the screen as well as you can hear.
Yeah, this is better.
This is better? Sure.
Yeah, this is much.
Thank you. Please let me know if there are any issues.
Yeah, please let us know. If there is any issues, you can put it in the group chat also so that we can able to hear.
Sure.
Okay, so moving ahead. Right, so we were looking at the product development part, then the data augmentation, improved analytics, right? Limited or imbalanced data sets holding back the ML models. We'll look at what ML models are and how the ML models help us in, in modeling our data and customizing the problems, solutions, etc. at a later stage. But this is just an introduction to that. Gen AI can create realistic synthetic data to supplement the existing data. This basically leads to more accurate and effective models, empowering better data-driven decision-making throughout the organization. And fraud detection and risk management. This is to protect your business from financial losses with Gen AI. It can identify the fraudulent patterns in real time and analyze financial data to predict potential risks. So as you can see, Gen AI has the potential to transform various aspects of our business. We'll be exploring these applications further throughout the sessions. So we explored the exciting world of generative AI. Now, let's look at many ways how it can empower the business growth. Gen AI offers a wide range of benefits across different departments, impacting everything from cost till the customer experience. Some of the key areas where it normally shines. The first one is reduced cost. So automating tasks currently done by humans, like generating product description, marketing copy, etc. Gen AI can do just that, freeing up valuable resources, hence reducing the labor cost. Then improved personalization. Want to create highly personalized experiences for the customers. Gen AI can analyze vast amounts of customer data sets and generate personalized marketing campaigns and products, as well as the recommendations, leading to increased satisfaction in sales. Then increased productivity. So we can simply stop wasting time on repetitive tasks. Gen AI can automate these tasks like generating a report, answering customers' inquiries, allowing your employees to focus on more complex and say strategic work. Then boosting the decision making. Gen AI can analyze vast data sets to identify patterns and trends that humans might miss normally. This translates into better data-driven decisions for product development, or it can be for marketing campaigns and many more. Increased efficiency is just because assume that streamline processes and workflows with Gen AI. Example, it can generate legal documents or translate languages with very high accuracy, leading to very efficient work environment. Improved customer experience, already we have discussed about the same in the previous slide, same customer satisfaction, all these. So just some of the ways Gen AI can revolutionize our business. We'll be exploring very specific applications in a later stage. Now, Gen AI is a crucial area of knowledge for business leaders like yourselves. While you may not be coding the next generation AI products, but understanding this technology offers significant advantages like strategic decision making. Gen AI presents a vast landscape of possibilities for innovation, automation, enhanced customer experiences, so on and so forth. Leaders who grasp Gen AI can make strategic decisions about how to leverage these capabilities to achieve your business goals and gain competitive edge. So competitive advantage will be the field of Gen AI is rapidly evolving with the potential to disrupt the entire industries. We can see a lot of examples in the last 1 year. By understanding this Gen AI, you can identify opportunities to implement these technologies ahead of your competitors, securing a significant advantage in the marketplace. Evaluation and investment. As Gen AI solutions become more prevalent, business leaders will encounter proposals for implementing them. Having a solid understanding of these terminologies and the technology empowers you to effectively evaluate these proposals and make informed investment decisions. Then talent acquisition management. The demand, there's a huge demand for skilled AI professionals. it's on the rise as Gen AI becomes more integrated into the businesses. Demonstrating your knowledge of and commitment to Gen AI technology will definitely help you attract and retain top talent in this crucial field. Then the risk management, ethical considerations will also come into picture. Like any other powerful technology, Gen AI also has potential risks like bias, misuse, etc. Leaders with Gen AI knowledge can establish responsible practices, mitigate these risks, and ensure the ethical implementation of Gen AI solutions within the organizations. Then communication and collaboration, effectively communicating the potential of Gen AI to stakeholders and collaborating with the Gen AI teams requires a proper understanding of the technology. This fosters the culture of innovation and bridges the gap between your business strategy and the technical implementation of this Gen AI solutions. So by understanding Gen AI, you will be well equipped to lead the businesses into the future, unlock the transformative potential of this technology, what it offers. So with that introduction to the Gen AI, now we will move ahead to the foundations that lead to this ultimate technology. So everything starts with the what is called as a data. Now, the whole process of model building depends upon the data set. So what machine learns is actually not from what data set that you give the model to learn, but it actually comes from the information that you extract from the data. So one example, I try to demonstrate the importance of information collection from the data set in this slide. So on the left most side, you can see that it actually shows you the Virat Kohli's scores innings by innings of all matches he played, let's say. This actually talks about a lot of information like which innings, what's the score, how many overs, right? And who was the opposition, which ground, and many other information related to that. This is the data what the, let's assume the TV channel has. So as soon as Virat Kohli comes for batting, assume that the TV channel displays this on the screen. So I will not be very happy to see that at all. Instead of that, what I'm interested to see is there on the right side of the screen, which says carrier summary. This is what is displayed on the screen whenever Virat Kohli comes to bat. So the difference is what you have on the right side is the information. What you have on the left side is the data set, right? So we will be able to understand a lot from the information rather than the data as it is. Because data is pretty much raw. We may not be able to go through each and every aspect of the data set that we have. But instead of that, if somebody extracts the information and presents it in front of us, that we'll be very happy. So the same thing happens even for the models. Normally, the data set which we collect it will be in the raw format. So it is expected that you try to represent that extracting the information and present it for the model. So that's one very simple analogy of the data and information. So this is very important for us to go ahead and understand this Gen AI concepts. So that's the first thing. Then the second aspect is that we'll look at different types of data. Now that the Gen AI, different tools that we see these days, different products which are in markets, they are mainly concentrating on two types of data. One is a text, because of even a lot of revolution happening in the field of natural language processing. So text is one data format. And the second one is images, vision related data. So this includes images or videos. So other than that, we can see that there is a tabular data format. This is most widely existing data format, represented in the form of rows and columns. Then there is something called as a time series data, the data which varies with the time, such as weather, different weather aspects, temperature, rainfall, humidity, etc., or the speech, right? When I speak, right, the magnitude of what I hear varies along with the time. So that's also a time series data. So these are the four fundamental types of data which do exist. So we can actually use these data formats to give it to machine after extracting some information, so that this these machines can learn from the data. Now, before going ahead to understand how the models are built, right? These models will be built for certain purposes. So what could be the purpose? When I have a data set with me and I want to do analytics on this data, this is very important because there will be a business goal in front of me. And in order to achieve that, I need to know my data. So that comes under the data analytics. We can perform 4 kinds of data analysis. The first one is descriptive. Basically, I'm not doing any mathematics over there. I simply ask, what is a question? I ask a question saying that I have a Virat Kohli complete data set with me. I ask how many times he scored 0, right? How many hundreds he scored, or how many 50 plus runs, right, etc. You see that I simply see the data set and I answer the question, right? This is descriptive analysis. Basically, we need statistics, data visualization, or some matrix algebra. This is sufficient to answer this kind of question. So the second one is diagnostic analysis. We can go a little bit deeper than the first question. That was what happened. Now we ask a question like why it happened. What could be the cause? Like, right? Maybe he scored he just between 0 to 20 in one of the matches. Maybe the analysis team will ask why. Maybe the answers could be right, depending upon the pitch conditions, or something will come as an answer because this is the reason this happened. So this is called as a diagnostic analysis. Again, we can perform this on the data set which we have collected to solve certain problems. But you see, the solution to these kind of questions need mathematical steps such as correlation, covariance, mutual information, entropy, etc. So we can see probability, statistics, etc. come into picture. Then another type of analytics we normally can perform is predictive. So here the question will be, what's going to happen next? I have collected enough data set, and from that data set, I want to predict what's going to happen, right? So in such case, maybe what I know which is the next match that's going to happen, where the Virat Kohli is going to play. I will ask what could be his score if he comes to bat. So you see that in this case, it's not simple mathematics. We need MLDL models coming into picture, along with probability calculus, statistics, and many other things. And the last one, right, is a prescriptive. This is something like, if I want to achieve this goal, what are the steps I need to take, right? This could be something like, I have my own YouTube channel. Let's assume I want to double my subscribers in next 2 months. What I have to do, right? So this is prescriptive. So the model has to give me the answers in terms of, okay, follow these steps to achieve that goal, right? So action is what you are going to ask. The result is predefined. I want to achieve that. So again, you see here, MLDL models come into picture. Data-driven optimization techniques are needed to solve this. And mathematics, definitely including calculus, algebra, optimization techniques, probability, all these are very much important for you. Now, so far, we understood that if you want to build something from scratch for this AI models, we need programming for sure, then mathematics, optimization techniques, plus fundamentally, mathematics has four legs that are all the four are important over here: probability, statistics, calculus, linear algebra. So let's look at the AI, ML, deep learning, and the generative AI, how they are related. So the outermost circle that you see on the screen is artificial intelligence, which we have defined. Here, our intention is to make machines intelligent. So we expect model to take the right decision at the right time. This is what is AI. Inside the AI, it's inside the AI capabilities. We have machine learning. Basically, this machine learning includes teaching the machines to build mathematical models by using statistical programming to either to classify or to make some predictions. Fundamentally, ML models, right, will be able to predict a number based upon the inputs that you give, or the machines can also will be able to classify. So this was the first objective when people tried to build the ML models. But later on, unsupervised learning came into picture, where even without any guidance from us, machines still can be able to solve a lot of other problems, right? So ML models basically try to solve your problems using statistics and programming. Then inside that, we have deep learning, and this is the something like upgraded version of machine learning, where people try to replicate human brains, how the human brain is going to work. They try to replicate that and try to teach the machines how to replicate human brain. The idea is actually very simple, but the implementation is what is taking a lot of time. So idea is that if I go back to the machine learning needs training. There is a lot of training data that is required. You have to use this data set collected. Maybe if I want to predict what's going to happen tomorrow in terms of the weather conditions, I might require past 10 years of data for the same location. I use that, I train the model, then the model will be able to predict what's going to happen tomorrow. What will be the rainfall? It may be able to predict with some accuracy, okay? Not 100%, maybe 90, 95%, let's say. Now, people want to eliminate this concept of training. Researchers identified that, why don't you try to replicate human brain? So the first step was neural networks. I'll come to the neural network in the upcoming slide. And later on, the neural networks were extended further to deep learning concepts. Here, the idea is no training. This again, right now, it's not the case. Still, the deep learning models that exist here need training, but ultimate goal, maybe after 10 years or 15 years, we may reach that state where training is not at all required. Why? We see that how a child learns to walk. There is no training. Initially, a child tries to get up. Maybe it falls over there. Next time, after trying 1 or 2 times, it's able to get up, then take a step ahead. Again, it falls. Again, it understands and it goes away. There is no data set that is available to understand how to train. Because human brain is capable of doing that, where directly the testing starts, testing fails, and brain learns. I should not do that. So that's the idea of researchers behind going to the deep learning concepts, where ultimately there should not be any training. The model should know each and everything. Again, let's go back to the human brain. If I see a person today, and the same person, if he or she comes in front of me tomorrow, my brain understands. Yes, I know him or I know her. I have seen him. I have seen her yesterday. If you want the same thing to be done by machine learning, you need to train, right? So again, you see our human brains they know each and every algorithm and when to apply which algorithm to identify or to solve the particular task. It knows. There is no training. So this is the fundamental idea behind deep learning models, right? But right now, whatever deep learning models we are using, it may be object recognition, or it may be even the Gen AI concepts, which will come towards the end of this. We see that there is training. Training is there right now, but ultimate goal is no training. So at the end of the deep learning concepts, right? After looking at different models under deep learning, we will reach what is called as a generative AI, which is the high-end models of deep learning. All right. So we understood that AI is a vast field within computer science that focuses on creating intelligent machines capable of, say, mimicking human cognitive abilities. Think about a chess playing computer or a recommendation system on your favorite streaming platform. These both examples are of AI in action. So AI machines can learn, reason, solve the problems, and make decisions. As we delve deeper, we will explore how AI is revolutionizing various industries, how it forms the foundations of exciting, advancements such as Gen AI. So if I want to quickly talk about the machine learning, it acts like a learning engine within the AI. It focuses on different algorithms that can improve automatically through the experience of data. So there is a requirement of data. Data is the fundamental point, which I have to provide to these kind of models. During the training process, they learn, and then you can use those models for your application. Okay. Imagine a spam filter in the email. More spam email it encounters, the better it gets at identifying them in future. So that's the power of machine learning. ML algorithms can learn from data to make predictions and the decisions without need for explicit programming. So there is a model. How to build the model is predefined. Just give the data, train it, and that's all. So we'll see how ML plays crucial role in various applications, including, let's say, the Gen AI. Now, as I introduced you the types of machine learning models that we can build, right? Here it comes. One is called as a supervised learning. And the second technique inside machine learning is called as unsupervised learning. So as the name suggests, supervised, there is a supervision that's happening. Whenever I give a data set, for the model to get trained, I will also give the correct answer to a particular question. So something like during the training, I asked that, okay, if this is a question, this is the right answer. If I teach in that way, that falls under the supervised learning. For example, take an example of image classification. So I have collected data set belonging to two classes. One is cat, one is dog. So when I give a input image for my model to get trained, assume that it's a cat image. I will also, along with the image, I will give a answer saying that if this image is given to you as a question, your answer should be cat. Like that. So if I train the model along with the right answers that is expected, it's called as supervised learning. And inside the supervised learning, we have two categorical solutions possible. One is called as a regression, and second one is classification. So regression is predicting a number like rainfall, I give the past data set and I'll tell that, okay, if this data set is given, you have to predict this number. Or the bike count required in, let's say, an electric taxi business. So how many number of bikes required for a particular week in a particular city, right? So this is a regression problem. So what the number of bikes needs to be predicted, right? It's a regression. It's a quantity. And second one is classification, like the other example I mentioned. You have classification, like let's say that I have 4 different categories of images. So cat, dog, table, chair, right? So any one of the image is given as input, and the machine needs to guess, okay, what is the class of this object. So this is classification. So result is categories, not continuous numbers, right? It has to be one of the 4 numbers. So that's a categorical solution. This whole concept belongs under the supervised learning of ML types. So as we have already discussed, this needs data set, and there is a training that is going to happen. So below which you can see different names of the models that we can build. They have been shown. So there is linear regression is one of the model. Then KNN, neural networks, trees, SVM, logistic regression, etc. So these are the different models. Just to introduce you some of the names I have written. At the same time, we have unsupervised learning on the other side, wherein there are no labels given along with the data. So I give an image of cat, but I don't have a label. Maybe I don't know that it is a cat, something like that. Normally, whenever we collect the data set, there are 2 possibilities. One is that I know how many classes are there in this data set. In such case, you will definitely go ahead with the supervised learning technique. If you have no idea, you have to go to the unsupervised learning, in which case you will ask the model. I collected 1,000 images from websites, let's assume, and I don't know how many classes are there. I don't know that there are cats, dogs, tables, and chairs in my data set. So what I do, I will ask the machine learning model itself to tell me how many number of classes are there. So unsupervised learning models are capable of identifying patterns in your data set, and it is going to tell me that, okay, you gave me 1,000 images, and among these 1,000 images, there are 4 classes. So that's the capability of unsupervised learning. So some of the names I have written: K-means, PCA for principal component analysis, etc. There are many algorithms available over here.
Oh, I would like to ask one question.
Yes, sure, please. Please go ahead, Tanya.
Yeah. So actually, as you said, can you please go with the previous slide?
Yeah, just 1 second. Yeah, this one, right?
Yes. So my question is, like, we used to see right now the social media like Instagram and other things. So they also use the AI ML in terms of providing the data. Or if, well, let's say I'm watching any video or doing anything on social media, I used to get some kind of data which is might be it is coming as per my search. So do you think like whether these kind of platform is using unsupervised or supervised, both the things?
Mainly unsupervised. There is something called as a clustering that is happening.
Okay.
Normally, it identifies because you see, for these platforms, there is no fixed answer available. You belong to which category? The platform has no idea, right?
Okay.
So the ML model, or normally DL model, deep learning models are running right now. They are basically capable of clustering you into a particular category, and for a category, what is the ad that needs to be shown is predefined by their tool. There again, there is some optimization that's happening on the background, and that will decide you belong to which category and what advertisement has to be shown to you, so that there is a lot of chance that you purchase that particular item,
Yeah,
right?
yeah,
Product,
yeah.
perfect. So that's how it works. Normally, the customer segmentation is a major problem solved by using unsupervised learning.
Okay, thank you.
Okay, sure. All right, so let's look at the supervised learning as an example, right? So if I talk about regression, regression is predicting a number. So one example is, let's assume that I want to purchase a house and I want to predict the house price at a location. So you see that the price of a house becomes a label, and what are the different parameters I have to look in order to decide a price. We call them as features. So it can be number of bedrooms, the square footage, the age of that building, and many other parameters. I'm showing only 3 here. So depending on these features, the label has to be predicted. So if I want the model to do this job, it falls under the regression category of supervised learning. I train the model saying that, okay, if the bedroom equal to 3 and square footage is 3292, age is 14, you have to predict 280000, like this. So you see that basically it is actually trying to fit a curve. It's trying to fit a curve. In this case, I try to show it in a very simple fashion as a straight line, but normally it may not be a straight line. It can be a multi-dimensional, higher degree, higher order, complex curve. So whenever a square footage is given, it should be able to predict a price. Again, I'm showing it in a simple one-dimensional plot, but normally as the features increase, we may not be able to visualize that because the data becomes multi-dimensional. So regression, commonly we use tree-related models. Just to give a name, there is something called as a decision tree, which is a good regressor model. Neural networks are also widely used for these regression purpose. K nearest neighbor, KNN, is another algorithm. And there are linear regression models available. So these are the models widely used for these regression purposes. So we give the features, machine has to predict a number, a continuous number. This can be anything. It can be 280,280,000.5386. It can be a real number. All right. So that is what we call as the regression. It falls under the supervised learning technique. Another supervised learning technique is a classification. Now, as I can see the graph on the screen, now you see here, it's not predicting a value, but any data sample given, the model should be able to tell that whether it's a star or whether it is not a star. Again, this is a very simple problem. We have only 2 classes, but if you consider my previous example, maybe the model has to learn to identify 4 different classes, like table, chair, cat, dog, like that. So this can be very complex problem. Multi-class classification may be a scenario, but just to understand that the problem, this is a good example, right? We have 2 classes here. Either the given data sample can be a star or it's not star. Again, machine has to understand how to draw this straight line itself, but now not covering all the data points, but to separate the data points. So that's the difference between, in terms of what model you are building, the capability of the model changes over here. Though the model tries to build a curve, but the curve should separate the classes. So that is why the classification problem is trying to identify the category of the data point, which you use as a question. And again, here we will be having the features and the label. Now you see the label has only 2 values, either 0 or 1. So discrete values are my label. That means it's going to be a classification problem. At the same time, if the labels are continuous numbers, then the problem that we are trying to solve is regression, which we discussed in the previous slide. Then we also have seen that these ML models can perform something called as unsupervised. Right. Unsupervised learning, basically there is no label associated with it, because maybe the reason is I myself have no idea what is this data set or I have collected. So in such cases, I don't have a label available. Everything that you have, every parameter that you have collected in your data set becomes only the features. In such case, if I plot the features, I can simply see that feature 1, feature 2, etc. have been simply plotted in the form of dots. Now, I don't know how many categories are there. I can ask the model, but these models are completely different from the models that fell under the supervised learning, because supervised learning models expect labels along with the data set, along with the features. But now, since we don't have it, unsupervised learning techniques, we can ask the question that, okay, tell me how many classes are there in this data. So example, I'll directly show you the result, how what exactly is going to happen. So there is a algorithm called k-means. It tries to identify the number of clusters in your data set. So this is example result. You can see that the model has identified, okay, there are 3 different classes in this, right? So depending upon the algorithm, it tries to explore the given data points and cluster them into different, put them into different clusters. So this is one example. There are many other problems which you can solve, such as there is another algorithm called the PCA, Principal Component Analysis. This tries to reduce the size of your data set in terms of columns. Example, let's look at this data set, what we see on the screen. There are 3 features. One is age, music, books, etc. Now, in order to decide something, maybe whether a person is going to purchase a particular book or not, in order to decide that, let's assume that the book name is not at all necessary, right? Maybe. So in such case, right, I can ask the machine learning model falling under the unsupervised learning case to tell me that to give me those columns which are not important, right? So when we have a lesser number of features like 2, 3, up to 10, this may not be very significant. Humans can identify and eliminate those columns, definitely. But you see, the practical data sets will have, say, number of columns equal to 100, right? In such cases, it becomes really impossible for humans to identify which are the columns that are not required. I can do it at random, but random solutions are, right, not acceptable, right? And the performance of your model will come down. Accuracy will come down to 10, 20, 30% from 80, 90% if you do that. So that's not suggested at all. So we have dimensionality reduction techniques falling under the unsupervised learning. So I have no idea, I have no clue that these columns are not important. In such case, I can ask the model to simply tell me that which of these columns are not important. So it can be performed very simple concepts such as a correlation analysis, etc. Right? There are different models available under this. One such example is PCA, Principal Component Analysis, which is widely used unsupervised learning technique to reduce the number of columns in your data set. So if you ask me a question, why should I reduce? I collected this data set. There's a lot of struggle in collection of this data set. Why do you want me to reduce? Right? To answer that, if you have larger the data set that you give, larger the size of your data set that you give to the model or the machine to learn, machine also struggles to understand, identify the patterns in this data. Okay, so if I give a 2 into 2 matrix, it's easy for us to remember. But if I give a 4 into 4 matrix, I struggle to recall and to understand or do any mathematics out of it. So the same thing happens even with our computers. Our computers are running on a processor. Processors basically struggle to handle larger data sets. So as much as possible, try to reduce the data size. Again, the very first principle we learned today comes into picture. Don't give the data, give the information. So as you reduce the number of columns into a lesser number, you are actually extracting the information from your data set, which is vital to solve your problem. All right. So with that, I'll move ahead. So this is the complete big picture of ML. Basically, we can see the machine learning at the center. There are three circles around this. One is supervised, one is unsupervised, and below that we have reinforcement. So supervised we have seen. Supervised is we can solve two more types of problems under it. One is regression, one is classification. So you can see the applications right side of the regression, which says new insights, process optimization, predictions, forecasting, etc. will be done over there. At the same time, if you look at the classification problems that can be solved under the supervision or supervised learning, this includes diagnostics, customer retention, image classification, fraud detection, etc. fall under the classification related problems. At the same time, unsupervised learning, we discussed two things. One is clustering and one is dimensionality reduction. So under the clustering, you see segmentation of the customers, targeted marketing, whom to target, which advertisement you need to show. This will be identified over there. Then the recommendation systems will be a part of clustering itself. Dimensionality reduction, you see, normally we hear big data, right? Again, this big data is to train the models with the big data collected as it is impossible. So you need to reduce the dimension of your data set, right? And the compression, in other words, I'm reducing the size of my data, keeping the information intact, means it's a compression. All right. Structure discovery, absolutely. Feature elicitation, one more application. All right. So those two things are highlighted so far. And there is something also called as reinforcement learning. Reinforcement learning is a hybrid approach, which there is partial training happening, and then you allow the model to learn by itself. There is supervised, there is unsupervised. You can even call it as a semi-supervised. So real-time decisions. So you will give some inputs about, okay, if this is the question, this is the answer, this is the question, this is the answer. Some of the questions you try to cover and give, and then you leave the model to learn by itself. So real-time decisions are something like that. Machine may encounter some situations which it has not learned at all during the training process, but still it has to go through, it has to take a right decision at that time. So real-time decisions, game-related AI, yes, the chessboard game, where the model, though there is a model built, but depending upon the opponent, the model is able to choose the best move so that its score increases. That's what is a game. Learning tasks, skill acquisition, robot navigation, etc. are coming under something called as a reinforcement learning. So if to put everything and of everything that we discussed under the machine learning as a workflow, this is what happens. You collect the data set, and if there is noise, you clean the data, right? Then you extract the information from your data set. That's what we call as features. In this slide, you can see a step called feature extraction, right? The feature extraction is collection of actual information from the raw data set. That will be done. Then there are different models available depending upon your problem. If you want to, sorry, if you want to classify the objects, then you will definitely go under the supervised learning. Select any of the models names I have shown earlier. Select the model, build the model. That's a training process. And give a unknown sample to the trained model as a question. And machine is going to give an answer saying that, yes, this test data is a cat. So basically, in order to understand the whole process, we collect the data, we clean the data, extract the features, build the model, and test them. And at the end, test them. So testing is absolutely necessary to understand the efficiency of my model that was built. right? We use several parameters to understand how good is the machine learning. One very simple and easy to understand parameter or a metric is accuracy. How accurate? I ask 10 questions in the test data. I give 10 questions, 10 different images. Out of 10 different images, how many are the correct classification? How many images the model could classify correctly? So that's a simple thing as accuracy. So this is what happens under ML, right? So, but when it comes to the product development phase, right, this is how the complete cycle looks like. So on the left side, you have a business problem. Business problem could be doubling your sales in the country, right? So I try to formulate that into a ML problem. So so far I understood that definitely in order to build a ML model, I need the data. So collect the data collection, pre-processing. Actually, we did not discuss something called as the EDA. So exploratory data analysis is one of the very important module which comes under the data science. So before we go to the machine learning or the deep learning or building any of the model, you have to have a very clear picture of what your data set is, how the data set looks like, what are the statistical parameters, and are there any outliers? How do you handle them, etc. These are different questions which one has to answer before going ahead with the model. So as a part of this EDA, there is a data visualization coming into picture, and if required, you may have to perform the data augmentation. So once the data set is ready, right, you will extract the actual information from this data set, which falls under the feature engineering. So that's the data processing block. Right, you move further to the right, which is a model. Just now we discussed the workflow of a ML model building process includes training, testing results in the evaluation, because you define a parameter like accuracy. I want to achieve this accuracy. Maybe there is a goal, something like that. You perform the evaluation. After that you check, will it meet my goal? So we have two options. If it is no, you come down and you go back to the data processing. Maybe there are several there may be several problems because of which I could not meet my business goal. But directly it takes back to the data processing, because there are many research papers available which says that, okay, the very basic point we need to check is your data set itself. Maybe your data set is not properly classified, properly categorized before giving it to the model. Something like I put some of the cat images inside the dog class, right? I say that while teaching the model, I say that I give the cat image as input, but I say it's a dog. Machine did not learn properly how to identify a cat. This could be as simple as that. Or the second scenario is data is not enough. Again, we get a lot of reference papers published in the past which say that these machine learning models require huge amount of data sets, because right, each and every aspects of the problem that we are trying to solve needs to be covered among those data sets, right? So that's why. So maybe I have to collect more data set, do a little bit of more augmentation, and then come back. So that's why the no will take you back to the data processing back. Whatever steps you have carried out inside the data processing, you may have to repeat or you may have to modify. At the same time, if the business goal is met, you will go to the deployment part. Deployment could be building an app or building a website, wherein right, you get the answer, that's fine. Otherwise, on the left side, you can see new data and retraining. This is very important for the deployed model. Normally, deployment includes implementing the same model on cloud, and continuously, there is something called as a continuous learning, continuous integration, and continuous deploy. CI/CD is one part of cloud. So this deployment basically happens in cloud. You put your model in cloud. Something very similar to, let's say that, okay, let's take an example of Amazon. Amazon has its model available in cloud. They have deployed it. And whenever a new customer logs in to this Amazon, it starts to learn his or her features. What normally this new user searches. what are the past, as time progresses, this new customer is going to purchase something. So at what time of year, what is being purchased, etc. So it actually keeps on monitoring, and then it starts suggesting items for the new user as well. You see that there is a new day, as soon as a new data enters into the environment, there is a retraining that is happening for the same model. So that's why it comes back to the data. Whichever new data enters into this deployed model, there may be a requirement of processing the data, again augmenting the data, extract the features, again train the model, and you keep on monitoring this. This is continuously monitoring of the deployed model. So the complete development cycle is what you see on the screen. All right, then after the machine learning, we discussed directly about the deep learning in the initial picture, but there is a gap. There's a bridge between the machine learning models and the deep learning model. Now, the very first question that someone can ask here is about, when already you have machine learning models and they are doing very fine, why do you need the deep learning model? So we have answered that people try to eliminate the concept of training, and the model which is ideal right now, it should be able to decide which particular algorithm it has to use to solve a particular given problem. Maybe the same model, assume that this is ideal scenario. There is a model which knows everything. Every algorithm is there inside that model, right? Whenever I ask a question saying that, will it rain tomorrow? It knows which is the best algorithm using which it can predict. At the same time, to the same model, I give another question of classification, dog and cat. The model also knows, okay, this is the best algorithm for classification of images, like that. Okay, so that's the ideal goal here. But directly we cannot transform the problems which are falling under machine learning into the deep learning. So as a first step of replication of human brain, people try to implement something called as artificial neural networks. Okay, so we have a question from Shraddha. Don't we have separate model for each of this? Yes. The machine learning models are different. Now, if we are using the machine learning models, we are the one. The responsibility is on us deciding which model I have to select to do which. What's your problem? So based on the problem, I have to select. I may select KNN for, let's say, prediction purpose, and I will definitely choose a boosting algorithm which falls under the machine learning for classification, categorization, etc. So you see that's again, I know because I have worked on that, and I have you have a knowledge. Since you have a knowledge, you will be able to do that. But what if, right? What if somebody has no idea, right? Which is the best algorithm for what purpose? In such case, deep learning is the one which is going to come for help in future. Okay, I hope I try to answer that question. So in order to achieve this, now you see the ANN comes into picture, neural network, which was a very first step, right? So some of the references will definitely say that ANN is inside the machine learning itself. Okay, accepted, right? But I think that this neural networks act like a bridge between the ML models and the deep learning models, right? So how it works, it actually, people try to replicate the human brain's capability, and they did not try to build a model which knows everything under ANN. They simply try to replicate how a human brain works. All right, so I'll try to show the what exactly I meant by replication of human brain. So on the top, you can see that that's the smallest part of the brain. We call it as a neuron. This is that part of a brain which is the smallest entity which can take biosignals as inputs, process the biosignal, and generate some sort of output. In the sense, this is the one entity which is capable of processing the bio or neurosignal, right? That's what you see on the top. On the left side, you can see X1, X2, X3 written. Those are the connections from the previous neurons, right? Those inputs will come from the previous neurons. Technical name, biological name is dendrite. Then you have a linear structure. There is a cell body. Many cells are connected one after the other. And towards the end, on the right side, you can see outputs coming, right? Again, it's called as an axon terminals. These terminals are connected to the neurons which are located after this. So the neuron can take inputs from many neurons previous to this, and a particular neuron can provide its processed outputs to the neurons which are located after this. So the same operation people try to replicate in the form of ANN. It's artificial neural network. So previously inside a brain, people understood that neurons are responsible. A dense connection of neurons are present inside human brain, using which the overall processing of signals by these neurons result in what we are capable of doing. We are able to move our hands, right? Look here and there, etc. All are controlled by these neurons ultimately, right? But not as a single entity, all together. When all neurons work together, yes, there is a result. So same thing. You can see that below is a representation of ANN, artificial neural network, wherein each of these circle represent a single neuron. So there is a technical term for this. It is each of this circle is called as a perceptron. So it's actual neuron inside a brain. You can call it as a perceptron under the artificial neural network concepts. So some of the neurons are responsible for collecting the input, so that those are located at the leftmost side. And there are some neurons we call it as hidden, right? Because they are not available for us to see. It's only the input and the output neurons are what we normally see in the artificial neural networks, right? Internally, you can have any number of neurons, right? They are not directly connected to the physical world at all, but they process the information given by the input neurons, and the processed outputs of hidden neurons are connected to the output, which can solve your problem like classification or any regression, etc. So this is what is a simple ANN. Simple neural network looks like this. So after the machine learning models, so people try to build these kind of models, which are, again, these models are not knowing everything. There is training. Again, ANN needs training. So you have to give a data set and you have to make them understand how to solve a given problem. So this is done by something called as a learning rule. Now, how the ANN, is there any advantage of shifting from ML models to the neural networks? If you ask that question, so I can show you the workflow here, which actually eliminates one of the steps from the workflow of machine learning. So can anybody identify what is which step we have eliminated here? I'll give 1 minute for you to think. You can answer orally or you can put your answers in the meeting chat as well. So compared to the machine learning workflow, this ANN workflow has one step less. So my question was, which is that step? Okay. All right. Let me wait for maybe another 10, 20 seconds. So anybody wants to guess? Let's see. So at the center, instead of the machine learning, we have ANN. So each of the circle that is present inside this ANN is a neuron. So I don't have a machine learning model here. Instead of that, I have a set of neurons. Let's say that complexly interconnected neurons are present inside. So no ML model. So definitely there is a ANN coming into picture, right? So on the left side, we can see inputs are provided. Directly inputs are connected to these complex network architecture, ANN. And ANN produces an answer, right? Whenever a test is given, it produces an answer, right? If you remember, in case of the machine learning model, I'll go back to show you the ones. Okay, so the training data cannot be given directly as it is, right? You had to extract the features. You have to convert your data set into the features, and features are given to this ML model. So here you can see this is the ML model which is present over there, and just right. Instead of doing this, now if I ask the question, compare and tell me the difference over here, right? You can see that there is no feature extraction. The meaning is I can give the data as it is, right? So that's one advantage compared to ML models. Why do you go to this ANN? The one answer we can say that, yes, there is no requirement of this. Again, we can see a lot of research papers which justify that even if you don't do the feature extraction and give the raw data as it is to the model, neural network performs good, right? Neural network can solve your problem, can classify, right? This is what people have proved, right? We can refer the various research papers that are available justifying this as well. Okay, so we can see that the neural networks training on the top, you can see training data. There is a learning rule. Now the question is, ML models have certain algorithms present over there. How do you train these neural networks? So training of neural networks is governed by something called as learning rules. So there are different learning rules associated with different types of neural networks. Select a learning rule associated with that and train, right? So that's how the neural networks get trained. Then give a input data. Neural network is already trained. It gives you an answer. Okay, so same thing is what I have shown in a different way below that. So I have a training data given as input. So neural network learns. Now the learned neural network is nothing but there is something called as a weight, which is a hyperparameter of the neural network. So when I say neural network learns, it means it optimizes the weights. Weights are the something like weighing functions associated with all the connections. So if there is a neuron connected to the next neuron, along with the arrow mark that you connect, right, there is a weight, there is a weighing function. So weighing functions are optimum means machine is able to solve the problem. All right, so that's what is required for us to know about the ANN. Now, after the neural networks, the next step is deep learning. Now, we understood that machine learning offers a very powerful approach to AI, but there is even more sophisticated, techniques. I think we have a question. I'll come back to that. Yeah, Shraddha. So the question is, weighing of data means variables. Okay, I'll come back to that. So just let me go back to the previous slide. Okay, so you can see that, right? Let's take an example of the last 3 neurons, right? The 2 neurons from the previous stage is connected to the very last neuron, and there are 2 arrow marks, right? The 2 neurons are connected to the last neuron, right? Using a connection. This connection, right, will have a it's a variable called weight. So that weight, what is the importance of a connection to make a decision, right, is called as a weight, right? This weight is very important because maybe in order to decide whether the image is cat or dog, the upper neuron's output is lesser weightage. It has lesser weightage compared to the lower neuron, right? So that means lower arrow mark will have a higher value, say 0.9, and the upper neuron, its output will be multiplied by a smaller variable, say 0.1. Whichever has lesser weightage, you multiply by a smaller number. That smaller number itself is a weight. So these weights are the hyperparameters using which machine in the sense the neural network learns how to identify or how to solve a given problem, right? So yes, it's a variable, but when I say the neural network has been trained, it knows the optimum weights to solve a given problem. So all these variables will change and come to and they become a constant at the end, so that using those weights, I can definitely classify, or I can basically solve any of the problem that is given to the neural network. Okay, I hope I try to answer the question. Let me know if you have any further doubts. So the next step after ANN is a deep learning. It's in short, normally it's abbreviated as DL. It's a subfield of machine learning that takes inspiration from the human brain, as we already have discussed. And we know that the complex network is there inside our brains because of the neuron connection. The deep learning utilizes artificial neural networks with multiple layers, right? So what do you mean by multiple layers? I'll try to show one more slide next, which actually justifies what do you mean by multiple layers. But ultimate goal is you are trying to mimic the structure of ANN, which I showed in the previous slide, but there will be many more layers compared to the single layered neuron I showed earlier. So this deep neural networks can process very complex data sets, right? Very complex, even videos can be processed by them. The speech signals can be processed by them, and the accuracy is remarkable. Okay, let's assume that I want to perform an image recognition. I want to build an image recognition software that can identify objects in a photograph with high precision. Right? There are multiple objects. So previous example I gave for neural network, the image contains only one object like cat or dog. Let's take up an example of building a ADAS system wherein a camera will capture the complete road scene, everything that is located in the road, and the computer which runs on board of a vehicle has a deep learning model which should be able to which should be capable of identifying each and every object on that road on a real time basis. Like there is a hump, there is a road sign saying that this is the speed, somebody is crossing the road, etc. You see that many parameters are, many objects are there. Whenever the multiple object detection comes into picture, neural network fails. All right, so that's why people think researchers thought that no, ANNs cannot solve our problem of our ultimate goal of having a single model capable of solving each and every problem. So yes, so they thought, okay, let's increase the number of layers, which led to something called as deep learning. Let me show you the deep learning architecture. So you see here, the number of neurons are you cannot compare basically with the ANN. ANN has 1 or 2 layers. That's all. That's the max, right? So maximum number of layers in the maximum number of hidden layers is just 1 or 2 in a simple ANN. All right. But whenever you want to go for very complex tasks, right, it is necessary that you need to increase the number of layers in a neuron, right? So that actually takes us to the deep. What is deep here? Deep is the number of layers. It's a deep layers present in my ANN structure that changes the whole scenario, and we enter into the deep learning concepts. All right, then. So in the deep learning, we have many models available. One such model is called as a recurrent neural network. So this is, what is the difference between this structure and the previous one? there is a feedback. You can see that the output layer, there is an arrow mark. Output layers connections have some of the connections going back to the hidden layer. This is just I'm just showing this for understanding purpose, but these connections are not simple. There will be complex number of connections from the output layer to the previous layers. These output layers can also be connected to the input layers, or any number of hidden layers that you have, there may be a connection. Right. Now, what could be the requirement? Because unless and until you have a real problem coming into picture, we will not go ahead and find something new. So my question to you is that what could be the reason, right, of giving the output of my model to the layers, to the hidden layers or input layers, wherever you make this feedback connection, right? We are doing this. So what could be the requirement? So I'll show you the previous one where there is no feedback connection. So this is called as a feed forward model. Technical term is feed forward. Whatever is spread from the left side will keep propagating towards the right, and there is no coming back. It's a feed forward. So the functions or the signals keep moving from left to right. It's a feed forward network. But now you see here, the one of the advanced DL architecture that I'm going to consider in today's session is recurrent neural networks. Neural network architecture is still there inside, but it's not feed forward. There is a feedback. So can you guess what could be the possible reason? All right, prediction accuracy. Train the model. Okay. Okay. All right. Let's discuss about this. Take up again. This kind of requirements come only when you try to solve a different problem than what you were trying to solve so far. The previous examples were very simple. Like I have a single image and I want to detect multiple objects in that image. Right. So image is static. Now let's take up an example of say NLP task, natural language processing. I give the text as input, and my model has to give me an answer in terms of prediction of a sentiment. Let's say that this is a product review. I give a product review as input to the input layer, right? But you see, the text processing happens in the form of word by word, right? So first word enters into the input layer. It is processed. It goes to the hidden layer. That provides an output, goes to the output layer. Output of the model is given at the output. Now you see, if I want to decide what is the sentiment of a movie review or a product review, you have to go through all the tokens, all the words in the data, right? So if there is a word which it says say good. If I consider only the word good, my model will predict it's a positive review. But maybe I also have to consider the previous word, which is not, because somebody in a review, somebody has written this movie is not good. So you see, the model needs to consider its previous input, the output corresponding to the previous input, along with the current input. Current input is good, but my previous input was not. So model has to remember, okay, in this text, there was a not. So not comes from the output in the form of a feedback, and the good comes as the current input. So altogether not good, you will be able to make a prediction saying that it's a negative review. Okay, I hope that is clear, right? So the feedback comes into picture whenever you are dealing with, this was a basic problem researchers encountered. So that's why they suggested, okay, don't go with the conventional way of building the models. You have to implement a recursive neural network. The first one suggested was the recurrent neural network. Right? So that's how the traditional neural networks are going to be replaced with the recurrent neural network whenever you want to remember what happened in the previous steps of a sequence. Right? So information comes in the form of a sequence, like as I mentioned, it's a sentence, or in general, it is a time series. So traditional neural networks, though they are very powerful for static data, they will struggle to handle these kind of sequences. So in case of a recurrent neural networks, or in short, it is RNN, they are special types. The architecture is very specifically designed to handle the sequential data, and they take care of the previous input as well while making a decision of the current input. So in other words, I can say that it can remember little bit about the context. Only a previous state can be remembered by these models. So in general, this is what is a representation. Output is fed back as input. In short, this is the representation, but basically this is the expanded view. As and when the new input comes to the same model, the past output also will be considered, right, to make a decision. So that's what is basically about the recurrent neural networks. Right. But now another challenge comes into picture. Under NLP itself, let's say summarization, right? I want, let's say that I want the model to summarize a text of 100 words. I give a text, 100 words are there. Again, if you analyze properly, recurrent neural networks will also fail because it can remember only one of the past input, right? Output corresponding to the previous input, it can remember. It can remember only that is the context. But if you want to summarize the text, you need to have a little bit of more, what you say, capability in terms of understanding. Okay. For that, we have a question here from Ramesh. When the feedback comes, will it not go and update the data? No, it will not update the data itself. Only the internal calculations that happen inside your deep learning model will change. That's all. Right? So since you are giving the output fed back as input, right? Only those connections and the weights associated with that connections will change. And because of which you can think that, okay, it can remember something related to the past. The actual mathematics will clearly make us understanding how this remembering concept of previous input actually justified. But since we are not touching the mathematical part over here, that I keep aside. Okay. So original data will not be altered at all. It's not going to update the data in any way. Okay. So only the connections will and the weights associated with them will make sure that its previous word will be remembered. Okay. All right. Let me know if you have any. So right now our problem is how do you remember the context of a very large text, like 100 words, 1,000 words, 2 pages, 3 pages, 10 pages, etc. In such case, even the RNNs will not come into picture because RNNs have short-term memory. So to overcome this, researchers have suggested, researchers have suggested something called as long short-term memory network. It's in short, it is LSTM network. All right. So LSTM network processes the data in a very similar way. The output of the present state will be given as input to the next state for sure. But there are few more internal adjustments made inside the network. Inside the network, you don't have a simple neural network architecture. You have different types of neural networks clubbed together to remember the very important aspects from the past. Let's take an example of say someone has written a review saying that maybe it's in 2 or 3 sentences about a movie, right? Initially, the very first sentence is that I did not like this movie at all. The music was bad, and something like that. Maybe 1 or 2 sentences he or she writes about the movie is bad. Then he or she will also say that, but I liked something, one aspect. I liked acting of some hero, maybe. Right. Now you see, if you use RNN, it can remember only one of the previous word, and by the time it processes the very last sentence, it remembers only one thing, that someone liked acting of a hero. It will say that it's a positive comment. It's not a negative comment. Right. But if you use something called as LSTM, long short-term memory network, it can remember the long, it has a long-term memory as well as a short-term memory, but it will not remember each and every word. So the internally, though I have given the actual structure here, we'll not go in pretty much detail about it because that needs a lot of mathematics to understand. So what happens here is there is every model, remember, that has a hidden state. Hidden state is remembering important context from the past. In the sense, in the very first sentence of the review, it said that I did not like this movie at all. So out of which did not, the not will be remembered as a hidden state. Okay. In the next sentence, maybe the review says let's say the music is very bad. Again, it remembers very bad, or the bad at least. So it actually, there's a weighing function which weighs, okay, there are more negative terms like did not like, very bad, like that, compared to the last sentence which says that I liked something. There is only one like, there are 2 dislikes. So this review is, maybe the model will classify this into a moderate review or bad review, negative review, something. So that's what is the upgradation in RNN. RNNs will be replaced by something called as a LSTM. Whenever your data set is large and you want the model to remember the contents or the important information in the data set for longer periods or the sequence. All right. So we understood the flow in which these the models are built and the AI has evolved so far, right? But let's say that I want to build the model for the whole language, right? When you say that this is my target is machine should know how to identify a language. In such case, you see, model should be trained with each and every word present in that language, right? Even LSTMs are not sufficient to do that, right? Because on a very long term, if you give 1000 words as input, definitely this hidden state will, the hidden state cannot retain each and every important information present in your very first, second, 10th sentence at all. So that's the problem. So, right, we have to move further, right? Which takes us to something called something more sophisticated, a new architecture called transformer models. So transformers are, you can think something like it's a groundbreaking neural network architecture. It's revolutionized to result in something called as LLMs, large language models. Now we are coming closer and closer to the Gen AI concepts. Maybe you definitely have heard something about LLMs, large language models, and the transformers, right? If you remember, the GPT, Chat GPT has a T in that, right? So if you expand the T, becomes a transformer, right? So anyway, we'll come to the Chat GPT and other tools later, but just to give a hint, right? We are very close, right? So transformers, as I mentioned, it's a groundbreaking architecture, which actually resulted in the upgraded transformer structures called LLMs, large language models. So unlike the RNNs or LSTMs that process information sequentially, the transformers can analyze the entire sequences at once. It's not sequential model like LSTM or RNN, which we saw earlier. Though there are complex models available inside the inside the RNNs and LSTMs, they are not at all capable of handling the complete text at once. So transformers are able to do that. They can analyze the complete sequences. The complete text you have entered as in the form of a question can be analyzed simultaneously. So that means it's a parallel processing technique. So this parallel processing technique allows them to capture very long range relationship between the words in a sequence. Now you give 10,000 words in a question. Yes, if there is a capacity for the LLM that you are using the transformers to process and understand the context of a 10,000 word this thing, definitely it will understand. Okay. So this is something very crucial in building a language model or a complex language representation. Right? You can imagine something like reading a sentence with a very twist at the end. The traditional language model might miss the connection between the beginning and the surprising conclusion that happens in the sentence. But transformers, because of their ability to analyze the entire sequence in a single step, that too simultaneously, will be definitely able to grasp this this concept and generate more coherent and human-like text. So I will show you one simple architecture, that's all. So anyway, we'll not go in pretty much detail, but you see that there are many paths in which the data actually can enter into the model, and it can generate multiple outputs simultaneously. So the bottom layer is where you feed in your questions, maybe the prompt which we write in ChatGPT or Google Gemini, etc. Right there, you enter a text and it can go into this, and very complex neural network architecture is there. And because of this complex structure, right, multiple outputs can simultaneously come over. Right, this is one such model, right? We have the GPT coming into picture. You see that GPT stands for Generative Pre-trained Transformer Model. GPT is the same. The ChatGPT has a GPT over there. So the GPT represents Generative Pre-trained Transformer. Transformers we understand. Pre-trained, so I don't have to train at all, right? Because ChatGPT has a GPT-4 model or GPT 3.5 available inside them. I can simply put a question. So model has already been trained to generate the answers for you for a specific question. So simultaneously, all the words in your question will be processed by the model, and model generates coherent answers at the output on the top. So whatever it generates, it actually is going to give you, show you as an answer, right? So since this has a capability of understanding the whole language, right, the output, the model has been trained in such a way that the output generated by these models are belonging to a particular language. It satisfies the requirements of a language, because whatever text it generates may not be a right way of putting it in a language format, right? Linguistic requirements are there. English has its own requirement. Like if you want to make a meaningful sentence, these words have to come after these, before this, etc. You have a lot of requirements, right? So everything will be met by these models, because what you are trying to build here is a language model. So transformers are basically capable of doing that. All right. So far we were discussing about text. The continuous text is fed as input, but there is other there are other requirements as well. So people try to explore and build models in a different scenario, wherein people try to generate something called as even the images, let's assume, right? So for that, we need something called as a generative adversarial networks. So these are also the advanced DL models, wherein these GANs are fascinating type of AI model. Basically, they utilize adversarial training process. What is adversarial? I will come to that. But because of this adversarial training process, they can generate the data which does not exist at all. such as images, music, even the codes can be generated over here. So just to simplify the whole scenario, I'll try to go to the next slide, wherein I can explain what exactly happens. So there are two models inside the GAN. GAN stands for Generative Adversarial Network. The word adversarial comes into picture because the training process, it requires adversarial approach. What is this adversarial approach? You can see the screen that there are two models. One is a generator model, one is a discriminator model. So the generator model is built to generate, let's take up an image itself, right? It has to generate the images. The whole idea of this particular, what you say, GAN is that I want to generate images which look very similar to my handwriting, but they're not actually my handwriting, but it is very similar images compared to my handwriting. Okay, so you can see that on the left side at the top, I have a training data. Let's assume that it's my handwriting. How I write 0 to 9, different samples, I have kept it over there, right? I take up one example from that, it's a 8, right? That's a real data which comes from the top. At the bottom, I have one model, right? Because all these models expect some input. Even if you give a noise as input, these models do work. Okay, again, a lot of research has been made in this, and we can read and understand the process of building this. But to keep it simple, there is a model which we call as generator, takes noise as input and generates a fake data. Now you need to train this generator model in such a way that it has to understand how I write this letter 8, this number 8, and it has to try to generate that 8 as much similar to the original data as possible. Now you see here, the sample or the fake data is not at all matching with the actual 8 which I write. Okay, right. Now this generator model, when you keep training, right, further and further, this model will be able to generate the 8 which actually matches to your real data. Let's say now, so there is a adversarial training coming into picture. There is another model present inside this. It is called as a discriminator. The job of a discriminator model is that it takes a real sample coming from the top, and it also takes the fake data generated by this generator model. And the job of this discriminator is simply to say that whether the sample data, that's actually the generator's output, is real or fake. Right. So the discriminator model has to be trained in such a way that how to identify the fake. Now, the final output of this model, I would like to put it in this way. The model is going to generate a output only if the discriminator says real for a fake image. Even for a fake image, when the discriminator says that, yes, this is real, in the sense generator has succeeded generating a very realistic image, then only this model gives an output. That's why nowadays you can see that images are, right, being created which looks almost real, right? Maybe if you look very carefully, only you may identify that it's not a real image, it's a fake image. But yes, right, this is the starting point of generating images, right? Now generative AI even does this, right? That's why we included this GANs in the structure. So far what we understood, we'll quickly try to look at that. So AI landscape has the outermost circle, right, which is artificial intelligence. Then inside that we have ML, right? So you have to give a data set, make the models to train using ML models, and you can do classification, regression, etc. Then the deep learning comes into picture. And at the end of deep learning, you have very complex models that are built for very specific purposes. And yes, so generative AI has a connection with all of these. Right now, before going further to the the Gen AI concepts, right? I want to discuss about how these trainings happen, because so far we discussed many times we said there is a training happening. I have a data set collected. At the same time, I need to have a testing as well. I need to do the testing as well. right? So this is what happens, right? Quickly, we'll look at how do you use the data set that you have collected for training as well as testing. Now, one option is that whenever, let's say I teach, I'm teaching, I will, if I disclose all the questions which can be asked on a particular concept, then there is no meaning for what you say testing, because you know all the questions. Definitely, you will be knowing the answers. You will write the answer. So it is ideal that you keep some of the questions that can be asked on a particular topic aside when you teach, and ask those questions as input. As a testing inputs. So that the same thing we'll do here. Now you see on the screen, there is an original data set marked in green color towards the left. We split the original data set into two pieces. One, I call it as a training set. Second one, I call it as a test set. Right. So training set will be used for training. Test set, machine has no clue unless and until it comes into the testing phase, right? Only when my students come to the test, they know that, okay, these are the test questions. These test questions were never appeared during my training process, right? So that's a different thing. Normally, this is an 80-20 ratio. If you collect 1,000 samples, 800 samples will be used for training, 200 samples will be used for testing. So that's the split. That's the split how it actually happens, right? So we can see that, yes, this is how it will be split. And the training set will be further subdivided into training set and validation, because after I teach for half an hour, I ask a question. If I get a correct answer, I understand that, yes, my students are learning in the direction in which I want. So that's the significance of something called as a training set. There is a validation set and the test set. So there is what you say, the train validation is what will happen automatically inside the model's training. And at the end, you give the, in the testing phase, you give all the questions that are present in the test set and you get the answer. Okay, so this is what normally happens. And once these models are built, normally we need to evaluate. So how do you evaluate the model? So model's performance, based upon the model's performance, you can say that whether the model is underfitting, overfitting, or moderately fitting. So look at the very first case, right, on the left. So the dots that you see on the screen are the data points. To fit this data points, model has drawn a straight line, right? So the points to straight line, the gap is more. This straight line is not a good fit at all. So this is actually called as a underfit. This model is not at all going to perform well. Let's move to the rightmost side. See, the same data sets, model has drawn a very complex degree 10 curve. It's very complex. I don't need this complex data set curve to represent this. Again, you can see, right, there is a lot of error, right, during the testing phase, because testing samples are the triangles that you see on the screen. From the triangle to the curve, there is a huge gap. Error is high. So training error is low, but the testing error is high. It's called as an overfitting. You don't need this much complex data curve at all. What you need is something very similar to the model number 2, which actually approximates, maybe a degree 2 function is used to approximate these data points, which we say it's a appropriate fit. All right, so let me try to give a good analogy to understand this underfitting and overfitting. All right, so I use a very small bat to hit a very giant animal, right? It's underfitting. My model is not at all enough to represent that. At the same time, on the right side, you can see that I use a machine gun to hit a very small creature. So that's overfitting. I'm choosing a very big model, but that is not at all required for the given complexity. All right. So that's what is this. So in order to understand the underfitting, model builds very simple, curve, such as a straight line. This is too simple to classify the star and not star classes. All right. At the same time, look at this, right? It is overfitting because model tries to build a very complex curve to separate these classes. Again, this is what we don't like. We call it as a overfitting. But what exactly we are looking for here is it's an appropriate fit. Okay, so that's what is coming here. Now I'll move further. We'll go one step ahead. We'll come closer to the Gen AI. Now that's a large language models, LLMs, right? So this LLMs are inside the generative AI. So this is the same curve which we were looking since the beginning. AI, ML, DL, Gen AI. Inside Gen AI, we know that there is a specific model called the transformer models, which are derived from the deep learning concepts, which can represent the whole language as such. And right, that's what takes us into the large language, LLMs. So at the heart of this generative AI, there is large language model. It's a foundation model within the Gen AI. Very powerful examples could be something like the GPT-4, or there is something called as a Cloud, a Llama. So these are the LLMs trained on massive data sets of text and code, allowing them to generate human quality text, translate languages, write different kinds of creative contents, answer any of your questions in a very informative way. Okay, I think I missed a question. Sorry, Ramesh. At point, we will say appropriate fitting. Yes, if I'll go back to answer your question. Sorry, I missed that question. So yes, if you say that, yeah, this is the one which is said to be appropriate, right? At what point? Okay, this is like our objective is during the validation, there should be minimum error. At the same time, the testing also should result in the minimum error. I will go back to one more slide to justify this point. Okay, normally we go ahead with something called as the training and the testing curves. These training and testing curves will show the errors or the mistakes made by the model during the training as well as testing. Look at this model 2. The training error is low. The testing error is also low. This is the point where you say that, okay, this is the model I have to choose. If you go to the model 1, training error is high, testing error is also high, not at all accepted. The model 3, which performs very well, very low for training, but the testing, you see, it is very high. Again, that is not required, not accepted. Okay, so at what point, right, you will select, okay, this is what I need, this is the model I have to choose. That is the model which shows low training error in the form of validation. Whenever you perform validation, error should be less. At the same time, testing error should also be very less.
So we have to do these permutations and combinations to figure out which is the appropriate model.
Initially, yes, definitely. Initially, to whenever you are starting the whole building the ML models, right? Definitely you have to do this, but after some experience, definitely you will be having some idea about, okay, maybe this is the model which I can start. Yes, subjective, perfect.
Hello, Prashant. But
yes,
the example which you showed, right? The example which you showed for that separation, that is clustering, I guess. So the overfitting example actually has very low test error as well, right? Correct? If you go below in your slides.
Yeah, I will show you.
For example. So if we go here in the third slide.
Next one, right?
Next to this one. Here test error is also low, right?
So no, this is training error. What you see on the screen is only training error.
Training error. Okay.
So I'll try to put it in a different way. It tries to, if the model is overfitting, model tries to learn each and everything from your training data, but it fails to generalize when it comes to the testing data. It fails in the testing, but it learns everything from the training data. That's why now you see here the model tries to identify each and every training data and separate them into 2 different classes. That's why the model is very complex. You see the curve is very complex. I cannot write an equation, right? But if you use this test data on this model, it fails because it tries to learn everything which is not required.
Okay.
Okay. Yeah, sure. So generalize. Model should not be very simple, like a straight line. We expect a moderately complex model. Now you see here, definitely there will be error. This model is going to make some error in the testing data. We are not expecting 100%, right? There can be some errors, but model should not be very complex, but model should be able to generalize when it comes to the testing data. So that's the point where we say that appropriate fitting. So this mathematically is justified by the previous slide which I shown you, where training and the testing errors are minimal. Okay.
So one very basic question.
Sure.
How do we, how do we get this, charts or the graphs, right? Is it that your output also generates? So each model, so let's say, I have trained, I have a data, right? I figure out the features, I give it to my specific model, whether it is written in Python or anywhere, I have the respective output, right? Now, where will I get this chart to understand that my model is overfitting or underfitting, or it's a fit for my use case?
Okay.
You're getting my question.
Yes,
how do I get this?
Yes,
how
yes.
do I get this graph to understand? Let's say I've used X model. Okay, I'm a beginner in let's say LLM, right? And I have used X model, which was available easily, right? I gave some data,
right?
I got the output. Now I'll train it continuously with some different samples of data. Now, where do I get this graph to figure out whether it is overfitting or underfitting?
Yes. So for every model, right, during the training, the model actually calculates something called as a loss. It's the error term, right? These error terms can be used to plot a graph directly. Okay, so there are some functions available. If you are using Python, there is a library in Python using which you can plot, like matplotlib, seaborn, or pie charts, etc. So there are different graphical interfaces available which you can call and you can visualize, right? So but in order to answer your question, from where you get these data samples, it's the error, right? Training error, right? At the same time, whenever you test the model, you also get another variable which holds the values corresponding to the errors it made or the loss it occurred during the testing. So those two are the variables which you need to look for each of the model, and then pass it to the plotting function, which will plot the graphs.
Okay.
Okay.
Understood.
Sure.
So each model will have it by default, right?
Yes. Each model will have a variable associated inside the model itself, which holds the loss value.
Got it. Sure.
Okay.
Thank you. Yeah.
All right. All right, so we enter into the field of large language models. And what is LLM? If we were looking at that, right? And we understood that, I think I covered this. Basically, right, it's a foundation for the generative AI concepts. Right. Let's try to have a closer look at this LLMs, right? These are the models which are built on something like these are trained on a massive scale, right? And imagine like there is a giant library, not filled with books, but with the words and the text data. LLMs are trained with on this, let's say, the vast amount of information, allowing them to understand the intricate relationship between each and every word and how they are used in different contexts, right? So think of it like a giant word library with complex connection between each of the words. By analyzing these connections, LLMs can learn the whole language. Okay, whole language of the data they are trained on. This allows them not only to process the information, but also to generate human-like text, because language itself has been modeled over them. right? Maybe it is from summary. You want a summary of something. Yes, it can do that because it knows the relationship between each and every word in a language and how they are used, what should come after what word, what should be the before word, etc. Everything it has an idea. So it can generate summaries, it can generate very creative content, right? Only certain parameters needs to be changed based upon the questions. So the training process involves feeding LLMs with massive amount of text data like articles, books, the codes, etc. So through this process, the model learns to identify the different patterns and relationship between the words, allowing it to generate its own text that is relevant and very coherent, right? Yes, Ramesh. Each word is used in multiple contexts, right? So it will, right? So this is a very general idea. Actually, this is what happens inside ChatGPT, but I'll go to it deeper and detailed image at a later stage. So assume that you are writing a prompt, word vectors. Now, normally the words that you write will be converted into a vector format. I will come to that as well slightly later. Assume that each word has been split into different tokens. That's W1, W2, WM. So there is a transformer model inside, right? Example chat GPT-4 inside the pro version of the chat GPT. So normally it analyzes your question. Since it is a NLP task, natural language processing task, internally the NLP is divided into two subfields. One is NLU, natural language understanding. In a sense, when somebody enters a natural language text, model tries to understand that. It can be the context or whatever information that it can gather from the input. So that's what comes over there. And that's what choose next most probable token, etc. There is a probabilistic calculation, right? Normally what happens, these models are trained to pick up the most suitable word that can come after a given word, right? So there is a probabilistic calculation. That's why you can see argmax, maximum argument of probability, P of, that's the mathematical notation. What is the highest probable word? So using, again, the model is not only calculating the probability, it also has a technique using which it selects language satisfying words. All right. So like that, output tokens are selected and combine the tokens to produce the output. This will be fed back because, right, there is a context understanding. So there is a feedback. So this is whatever we were discussing so far is actually can be seen on a realistic scenario. In this is what is happening inside the ChatGPT whenever I ask a question. All right, let me go ahead. Let me show you the evolution of LLMs. What are the different LLMs and since when the LLM research is happening and what are the products, what are the different LLM models that are available, right? At different intervals of time. You can see starting from 2019, the Google developed the T5. 2020 GPT-3 came into picture, right? Some of them we know, we have heard their names. Some of them we may not have come across so far. So again, this curve shows the llama, right? It can also show the lambda models present. And you can also, can you identify any other models? Meta has developed the OPT model, llama model in 2023, everything. The Google has developed a BARD. Now it is Gemini, but the previous year it was known as BARD model. So everything is there. So you can see that this is how the LLMs were developed, representing the different language models. All right, I will go ahead. I will show you the evolution of LLMs in the form of different companies and their products. So in the x-axis, horizontal axis, leftmost side is the hardware. Which all the companies are actually generating the hardware that are required to process this huge amount of data. See, one point I missed when I shifted from machine learning to deep learning. Machine learning models are light. You can train them even on a CPU. But the deep learning models are massive. There is a requirement of huge computational power. For example, a simple object detection, multiple object detection model, which is built, let's say, to identify different objects on a road scenario. Very simple model. It may run for 2 days if you run on a CPU. For that itself, that purpose, NVIDIA and other, even Google has their own TPU, tensor processing units. NVIDIA develops GPUs, which are really helpful in training the, the deep learning models. So on a CPU, if it runs for 2 days, 2 full days, on a GPU, it will run within, let's say, 1.5 hour or 2 hours max. So that's how they're fast. Okay. So on the leftmost side, the hardware comes into picture. So as you move horizontally, you can see the different aspects required to build a complete product. So hardware is required, cloud. So which all companies provide cloud support for this? You can see Azure, Microsoft is doing that, and you can have a Google Cloud at the top, AWS above that. So those are the different companies, different solutions available for you to apply these models on cloud. Then you can see model hubs, ML frameworks, and the models, right? So these are next, you can see as you move above that, above the model, you can see Meta developing Llama based on a PyTorch environment, GPT-4 and 3 from OpenAI, right? There is Lambda, there is Palm from the Google, there is Bloom coming from Hugging Face, and so on. There are many, these are some of the, models. Then fine-tuning operations, right? What you can use for fine-tuning these models. Then the APIs, right? There is LangChain, right? There is GPT Index, there is Writer coming up. So all these are the options available for framework API-based thing. Then what are the ultimate applications, right? So you can see Bing, Office, etc. are the products coming from Microsoft, which is also supporting the GitHub Copilot. Above that, ChatGPT, which is a product of OpenAI, right? And Bard, right now, it's not Bard, it's a Gemini, but again, it's coming from Google. Like that, you can see Jasper, right? There is a Grammarly, Snap, and many other tools are there, but right, we are simply representing only a few of them. So this is a big picture, which actually shows you, right, different tech giants, what are their supports available for, right? Some of them may be free, open source, some of them you may have to pay to use those tools for sure, right? But this gives you a big picture about, again, the LLMs, different types of LLMs, how they are being used, what are the other tools that you may have to learn if you want to use them in your products. Okay, so this is how the LLMs in the ChatGPT works. So I'll try to keep it as simple as possible. So at the center, you can see, right, there is something called as store embeddings in vector database. This is what I call it as a heart of the ChatGPT's database. Because anyway, we know that in order to train these models, we need huge amount of text. These huge amount of text should be represented in such a format that they can be read and they can be read very quickly. So there is something called as a vector database format. But basically, you need to understand something called as embedding. Embedding is a technique used to convert text into numbers. Because though we type ABCD from the keyboard of my computer, but my computer does not understand this ABCD. It will normally someone will convert these typed ABCD into numbers, and that numbers will go into the computer. It can be ASCII for English and related characters. But when it comes to a global language representation, it will be in the form of Unicode. Right? Every language, every character in every language in the world has a Unicode generated. So that code will be passed on to the machine, which will be in the numerical format. So that's an embedding. And there is a vector database, which actually is something very unique. And that vector database, maybe I'll try to tell you what is this vector database. Think of these databases as a sophisticated filling cabinets that store information not as a text, but a very unique numerical codes. That's all, right? So that's why it is a vector database, we call it. So these embeddings capture the essence of a piece of a text, like meaning, relationship between each of the words, etc. So that's what will be done over there. That's the heart. And others are very straightforward. We already have discussed about this. And right, the creation of embeddings or the vectors will be done from the large documents that are actually collected by maybe OpenAI. OpenAI has a huge database which consists of, for English, they have a database. From that database, including the text, books, and anything that contains text will be converted into a embedding or a vector representing the numerical format of those texts, will be put up into a vector database. Any query that comes will be converted into another embedding, another vector, and compared with this vector, so that, right, it can understand the query, right, and the LLM which is present over there understands this question, the context of the question, and generates the response out of it. That's how the LLMs in the ChatGPT is going to work. Already we have seen a simple diagram earlier. This is actually actual representation of that. All right, then very similar things will happen even in the Google Gemini. Right, this is the first time we are looking at the Gemini, but fundamentally, the way or the embedding technique that the Google uses will be different compared to the ChatGPT. Other than that, there will not be any difference, right? And the LLM model, the data set which they have used will be different, because Google has their own data set, right, which they have collected, and they use that. And the embedding technique that you use is different, because of which the LLM model they build is also going to be different. Okay, so that's the difference. Again, I want you to get introduced to the LLM, which was built by Meta, and it is called as Large Language Model of Meta AI. In short form, it's Llama, LLAM. So most recently, they have released Llama 2 as well. But the very important difference that exists between this model and the previous two models is that the Llama is open source. It is available for us to download and to train for our requirements, whereas the other two models are not freely available, right? If you pay them, get the pro version, then you can modify according to your usage. All right, so that's the those are the differences that exist between the products or the LLMs developed by different tech giants. Okay, so this is what is going to happen in the model comparison, because I want to show you that how these models are different, and different in the sense in terms of the output generated by these models, right? How they are different, which will definitely make sure that we understand that the model's training scenarios are different. The model's internal architectures are also different. Probabilistic calculation that happen inside the models are different, because the training happened in a diverse different scenarios. So just to understand that, so let's try to compare the models. Okay, so what I will try to do now is, right, a very quick session on the, okay, this is what I already have run, but if you want to run on your side, please open ChatGPT or any other tool. You can even use the Google, the Bing Copilot, or even the Google's Gemini. You can do that. Okay, so I want to, this is my prompt, right? So we'll come to the prompt in the upcoming slide. But the question that you normally ask in the form of a text to have a conversation with the LLM is what we call as prompt, right? So this whole thing is a prompt. Now, definitely you will have a question saying that, why do you want to have to write this big, right? What you see in the whole slide is my input. This is the prompt. I'll justify why this is needed at a later stage, but just look at this, right? I am asking the LLM, to list product names for a shoe that fits any foot size in the style of Steve Jobs, right? So what I am expecting, I'll type up that, return the results as a comma separated list in the following format. So a product description comes into picture, a shoe that fits any foot size. And this is the actual question, and this is the format in which I'm expecting the answers from the model. Product name should come in the list of 3 product names. Okay, so yes, I think Ramesh has an answer, right? We'll discuss the solution. Thank you for your answer. So in this, I also specify this is my example. So example, I mentioned that, okay, if at all I ask a question about the refrigerator, this is the expected answer. So since I mentioned that there is a Steve Jobs coming into picture, and I know that his products are starting with I, like iPhone and many things. Like that, I expected I at the beginning. So product names are so and so. I give 3 such different examples. One for a watch, maybe, and home milk maker, milkshake maker, etc. This is what I specify. Okay, so already Ramesh has tried in ChatGPT. Okay, so when I ran this on different, let's say, models, right? This is what was the results, right? So you can see, as we know that LLMs essentially, right, since they have been trained on a giant, what do you say, text data format, right? They are actually able to generate this text. But because of the training scenario, training data set, the internal architecture, they are different. The answers generated by each one will be different. So that's what I wanted to show you. For the same set of questions I asked, my prompt remains same. But depending on the model, right, the result is different. The chat GPT or the GPT-4 gives the answer where it actually understands the context in which I asked the question. It understands the question properly, and the scenario related to the Steve Jobs. It actually identified that, okay, everything needs to be I, starting with I. That actually has been identified over there. Cloud to, for some extent, one of the answer is starting with I, but others, no. Maybe it missed the, what do you say, the identifying the context in this range, because it may not have been trained in pretty much depth over here. Okay, maybe that's a solution. Okay, that's the reason. That could be the reason. And when it comes to the Llama 2, you can see that it actually generates a lot of text over it. Sure, here are the 3 product names and so, right? And it is not following the output format what I expected. Though, yes, the answers of the products actually are following the instruction I have given. I wanted to start with I, so I gave a hint saying that Steve Jobs, it could identify, but it's not in the format. So you see that there will be differences. Okay. Yes, that's a good observation, Ramesh. All the 3 have given I fit, right? Because now you can also understand this in such a way that, yes, there is something common as well, because, right, they are generating one of the text as common means, yes, they have been trained in identifying one of the aspects, right? But after that, there is difference that's coming, right? Okay, so now we understood so far that there are 2 different types. One is open source, right? And one is non-open source. We were again discussing only about the different models by different tech giants related to the text, right? But yes, there are even generative AI models that are available for vision related tasks, generating images, generating videos. Yes, you can see these are the 2 different sets of models. The first set of models are specifically designed for vision oriented tasks, but they are open source. Okay, so you can see the names here, right? If at all, I just put these here just because we should have some idea, okay, where to go, which model to use, or where to start with if I have an objective of generating images. So there are open source, free to use, you can download, you can modify, you can do coding, and yes, you can do that. Maybe the results may not be as accurate as the ones which you get from the non-open source code, because those models are pre-trained to in such a way that, right, they can generate each and every type of image that you expect, but yes, at the cost of a license. Right, so Dell, AT, Imagen, Midjourney are very famous, right? I hope you have heard most of these names. Okay, so since we were discussing all the way about the text, right? Here we can see some of the business use cases of generative AI for images and videos. Maybe we can use it in the product design and prototyping. I'm going to come. I have included the product design prototyping hands-on session, which will come in tomorrow's session. Again, other application could be content creation. We'll see one hands-on over there as well, and other application could be e-commerce, personalization, right? Marketing, advertising, right? So these are some of the examples where we can have a business use case for this. All right. So then I want you to get introduced to another word called as LangChain. Already in one of the previous slides, we saw the word LangChain coming into the picture. So basically, let's imagine that you want to build a powerful application by using the large language models, but the whole process is very complex. In such scenarios, the LangChain comes in the picture. It's a open source framework designed to simplify the development process of the LLM-driven applications. So LangChain is something like a orchestra conductor for LLMs. It takes care of complex behind the scene tasks, allowing you to focus on the creative aspects of your application. For instance, LangChain simplifies the workflows like prompt chaining, where you feed the LLM outputs as input to the next step. Right? This can be simplified over there. It also streamlines the data integration, allowing you to seamlessly connect your LLM with various data sources. Right? Let's assume that I'm building a LLM, and my LLM takes input from various resources. So there has to be a data integration that, again, this LangChain can take care of that. Right? Another key benefit of LangChain is its model agnostic nature. This means LangChain provides tools that work with multiple LLMs, offering you a lot of flexibility. Whether you want to use OpenAI's GPT-3 or maybe Google's Lambda or any other emerging model, or there may be a customized model which you have yourself, you want to integrate with. So everything can be done at ease if you use LangChain. So is it worth? So consider using LangChain if you are building a very complex LLM application that involves multiple steps and require data from various resources. Then only you go for LangChain. Otherwise, customized LLM, because we saw that LLMs use transformers and they are massive, right? So for a single language related applications, yes, a simple LLM is sufficient according to me. But if you are collecting data set from various resources and you integrate all of them using multiple LLM models, yes, then you have to go to something called as a LangChain. So this is what is the input that I can give related to the LangChain, whether to use a LangChain or not. Okay, right. So we'll move to the next aspect. So that's called as a prompt engineering. Now, somebody well said in one of the documents I saw this, what you see on the rightmost side, towards the end, he writes, as AI research, Andre Capati quips, now the hottest programming language is English. This is what he says. That means, right, that that's what is the importance of English nowadays, because of availability of the generative AI and the LLMs, right? So you don't have to know the coding language at all. If you know a good English, and if you can put the words properly to communicate your question to this LLMs, that's enough. Model will write the code for you, right? So that's a hint about the importance of writing the prompts in the correct way. So that's what leads us to something called as the large language models and its usage in terms of prompt engineering. Okay, so what is a prompt engineering? If you ask that question, it's the key to get the actual or the best out of a large language model, right? Which is used for generation of a text or video or something. Now, it's the input that you provide. Normally, it's a text itself, because these models are very well built to understand the natural language. So since the natural language is the most convenient format is a text or even speech, again, some of the tools are allowing you to give speech as input. So there is a speech to text conversion happening on the background. And then it is again the natural language itself. So you can see that all these AI models like ChatGPT, Midjourney, they take the text as input. Okay, fine. So let's look at what exactly is the prompt doing here, right? So let me try to show you one of the result. So this is an example of a prompt input, right? Example, the prompt name generator. Just now we have seen this. You can see the question is different. The input is not as detailed as I had shown earlier. So you can see that, can I have a list of product names for a pair of shoes that can fit any foot size? Very simple question. I try to keep the question as simple as possible here. And you can see that this is the result. So this is a list of the product names for a pair of shoes that can fit any foot size. Okay. Right, you saw this now. So what happens if you try to keep the prompt in the as basic format as possible, right? Normally what happens is there may not be any direction in the output. So this actually is the previous example. I'm talking about this example, right? This input basically lacks details on the desired output styling, right? Maybe the number of words, or may not be any, you have not specified any real world application for this. Okay, so that's the basic then unformatted. So this actually has no consistent format. So maybe the general output will also be in the most general format. That's what we can expect here. So when you miss some of the samples, so result in terms of the consistency, you don't have this. Then, right, missing examples as well. So no reference points. If it's always expected that we give some reference points for the models to generate, right? But in this case, you can see, no, I have not given any of the examples. So evaluation, right? How do I evaluate this particular model is, again, I have not given anything over here. So no quality measurement happening here. And task division, right? So that also you cannot see here. Think of a product naming as a multi-step process. A single prompt might overwhelm the AI by asking everything at once. So normally you can expect, you can divide the prompt into several tasks, and one by one you can ask. This is what is normally expected. All right, so let me try to elaborate that. What are the core principles that one has to follow, right? While crafting the prompts, right? So whenever it comes to the crafting crafting the prompt, we need to take care of the following. Now, whenever we try to give some inputs, think of the LLMs as a language masters trained on massive data sets of text and code. When you provide them with a prompt, they essentially try to predict the next word and its next word, building upon your initial instruction. So this prediction process incorporates, say, bit of randomness controlled by a internal parameter called as temperature. Okay, and the art of prompt engineering lies in harnessing this power. So crafting a well-structured and informative prompts, you can elevate the responses generated by LLMs beyond the average, right? So if I consider the answer that I got earlier as a average answer, I will show you what happens if you modify the same question satisfying all the conditions that we are discussing here, right? And the efficiency, we have to optimize this for efficiency for sure. It's important to consider the cost effectiveness as well. Some platforms, such as OpenAI, charge based on the number of tokens you use during the prompt and the response. In the sense, unless and I ask a very simple question, model gives you a very general answer, which is not sufficient for me. So I ask the same question once again, right? Different way. That answer is also not, I'm not satisfied. I keep asking the questions. That means you are charged more and more, right? So that's why, right? Whenever you use this the paid versions of the tools, right? So the skilled prompt engineers come into picture. They strive to create prompts that are very concise, delivering high quality, reliable results while minimizing the cost. Okay, this is where the very first example comes into picture, right? I will show you where we satisfied all the 5 conditions we discussed earlier. Okay, we'll come to that, right? So this is the answer. Anyway, you know this, so I go ahead. So what are the requirements? 5 fundamental principles everyone has to understand. Everyone has to satisfy whenever writing a prompt, right? So 5 points are there. So whenever you try to write a prompt, imagine yourself as an orchestra conductor guiding powerful LLMs to produce the desired outcome. So effective prompting is the key to achieve this. So we will explore the 5 core principles that elevate your prompting or prompt crafting skills. So the very first one is providing a very clear direction. So the first principle is all about giving the LLM a clear direction. Think of it as setting the stage on the play. So do you want a formal report or a light thread poem? What do you want? You have to suggest there, okay? And you want the LLM to emulate the writing style of a famous author. So you can specify that. That is the setting up of the stage. The more specific you are in describing the desired style or the referencing to a relevant persona, the better the LLM will understand your intent and tailor its response accordingly. So that's the principle number 1. Then the second one, specifying the format. So just like the stage play follows a structure, so you should do the same thing with your LLM's output. So the second principle involves specifying the format of the response. Do you need a bullet style listing, or you want to create a story, you want to get an email, etc. Clearly defining this structure ensures the LLM generates the output that aligns perfectly with your requirements. That's the step number 2. So principle 3 is power of examples. Imagine showing a child pictures of different animals to help them identify a dog. The same concept applies in prompting the LLMs. By including diverse examples where the task was done correctly, you provide the LLM with a valuable reference point. So these examples will help the LLMs understanding the expectations and improve its ability to generate similar outputs in future. Then evaluating and refining, right? Very important. So just like any creative endeavor, crafting effective prompts involves it's a iterative process. So this particular fourth principle basically emphasizes the importance of evaluating the quality of LLM responses, identify errors, rate the overall quality, and analyze what factors within your prompt seem to drive better performance. Is it the length of the prompt? Is any specific word of choice? This analysis allows you continuously to refine your prompts. Definitely, that leads consistently towards the better results. And the fifth principle, divide and conquer complex tasks. So don't put all the questions in a single prompt. That's the idea. So some tasks might be too complex for a single prompt. We need to break down the intricate goals into smaller, more manageable steps. Then one can chain multiple prompts all together, guiding the LLM through each of the steps in a sequential fashion. So this approach offers more nuanced control over the LLM's output, allowing you to tackle very challenging tasks very easily. Okay, so let me go back to the example and let's try to mark where we applied all these 5 different principles. So you can see on the top, right? That's the same question, right? Which says brainstorm the list of products, shoes, they're of any size, and then in the style of Steve Jobs, it's a direction, right? This is where I describe the desired style in detail, and there is a reference given in the form of a person, right? Then in the next line, return the results as comma separated list in the format. So this is the second, this is where I try to satisfy the second principle. Okay, specify the format. I'm defining what rules to be followed by the LLM and in what format we are expecting this. Yeah, we are closing in 1 or 2 slides. One more slide connected with this I have. After that, we can close. All right. Providing the examples. You can see that examples is I have written over there, using which it understands that, okay, these are the examples, right? And evaluating the quality, right? Again, you can see that, right? This is what I came to this particular step after rewriting the codes again and again. So this is 10 on 10. This is it's the 10th time you are doing this, right? I'm just writing the same thing again here just to show that this is the 10th time. But normally, if you follow the principle within 2 or 3 steps, right, you will get the answer. Right? I have one more part in the same question. I didn't include the same question in the prompt. I kept it as a separate one. So divide the labor. You see the next question. I'll go to the next slide. So here, I added another question to that. So that is what you can see here. ChatGPT says, I asked the question, okay, based upon their catchiness, uniqueness, and simplicity, give me a table format and give the rating 1 to 5. So now you see that it actually had given me 3 different names. So what is the catchiness? What is the uniqueness? What is the simplicity score of each of those? It actually shows me. That's it. That's how I divided the job that I have given here. Okay, so that's the example which I wanted to show you, where we satisfied all the 5 requirements. Okay, so anyway, we have come to the end, right? I had a few more examples related to the image generation using where we satisfy all the 5 same principles every week. Okay, so that's all. That's all for the day. Do we have any questions? Please let me know. Otherwise, we are good to wind up for the day.
Yeah.
So apart from prompt engineering, will we be covering fine tuning and other
Yes.
Okay.
Yeah. In tomorrow's session, we'll be mostly concentrating on hands-on itself. Okay. Including the fine-tuning part.
Okay. Thank you.
Sure.
Thank you, Prashant. Thank you so much. I think it was very insightful session. I would request all the participants, all the learners, probably you can share your view, how you find the training, the first day at least. If you can take, 1 or 2 lines, it will be really great. And if you want to add any suggestions, please feel free to, add. I request Payal, Mr. Bhaskar. Okay, thank you, Vijay. Thank you so much. It was a great session. You mentioned Himanshu, you wanted to add, Arif sir, Mahesh, you want to add anything from your end? Please do let us know. Okay, thank you, Shraddha. Okay, great. Thank you, Mr. Ramesh. Okay. Any such thing you want us to cover, like Himanshu have mentioned that thank you Ramesh, Mahesh, that Himanshu have mentioned fine tuning would be a part of this thing if you can add. So anyone? Thank you, Ganesh-san. Thank you. There's little info. Okay. Anything to be added? Please do let us know. Thank you, Himanshu. Thank you, Asim sir. Yeah. Very informative session. Okay. Real-time examples. Right. Absolutely. So tomorrow, as I mentioned, that we'll be going for hands-on. Yes. Using daily tools. Yes, daily tasks. Definitely. Daily tasks would be, we'll be taking those hands-on sessions. Okay. Now, one more request is from our end. I will be sharing you, the probably a link. You can share us in a feedback form. It's a kind of feedback form is there. You can mention it there. And also I'll be sharing one more link that would be talking about the certificate name. So please you mention your name as should be reflecting in the certificate, and as well as the recording access should be given to which email ID. So these two things probably if you can share, I'll share you the links. You can fill those links and share it back, right?
So over email or over here in the chat
Yeah, I will be sharing through WhatsApp as well as here also
WhatsApp.
I'll be sharing those two links. You can go through and you can.
Okay.
And any suggestions, please feel free to reach out to us. We will be conducting this kind of sessions in more in numbers. Prashant is there with us, and we will be conducting more insightful sessions. If you have any one from your team colleagues, please do refer us, like the way we have reached out to Bhaskar and Payal, everyone. So please do
Sure.
request to your team members.
Definitely.
Okay. Thank you, everyone. So we'll close it today, and I'll share you these two links here and also in our group. And we'll again come back at 6:30 IST tomorrow, and we'll continue our session from there.
Yes, sure, definitely.
Thank you, sir. Thank you.
6:30, right? 6:30, right?
Yes, 6:30 IST. Yeah, Indian Standard Time. It is
Sure,
6:30.
thank you.
And Vijay.
There's no change.
No changes, the timing. Absolutely same link. Please do join us, and we'll be starting. And we'll be doing a lot of hands-on sessions tomorrow going forward.
Okay.
Thank you, Ganesh.
Thank you all.
Thank you, everyone. See you tomorrow.
Thank you, everyone. Thank you so much.
Thank you.
See you tomorrow.